All right. Thanks everyone for coming. Appreciate your time. Recording this, going to put it up on YouTube. I heard from Michael Hocko. He sends his apologies. He can't make this time, so he's very much looking forward to reviewing the video when he sees it. Yeah, it's been a few weeks since we last spoke. Thanks to the Christmas break. Hope everyone had a good Christmas for those to celebrate it. I think we're about to lose some people for Chinese New Year. That's usually around this time. But hey, that's this time of year for you. So just a quick review. We got 3 important patch series in related to Folios for 5.17. Linus took the slab patches that Vastamil picked up and did a lot of good work on. So thanks for that. Good job. And Linus also took both the patch series that I was sending him, which was IOMAP and XFS, and he also took the page cache patches. So that actually puts us in a really good place. Some of you may have seen I sent out a series of about 12 patches, which actually starts using large folios in the page cache. That is, it'll create them in the reader head path. Those patches are actually a little bit buggy, and I've fixed those locally, but I haven't sent out a new version of them yet. I don't know if I'm going to bother sending out a new version of them, at least not before RC1, which is of course due on Sunday. So,
Matthew, hi. Can I ask about like split fish page or XFS pages? So you were saying that you cannot split it because of elevated ref count due to private.
yes.
Is it like only ref count, or we need also handle some metadata that private points to get page splitted or something?
Right. Okay. Yeah. So this is something that memory management people aren't going to know much about. So what XFS does is it's kind of its replacement for buffer heads. So it contains a certain amount of information about little pieces of the page. So there's basically 1 bit per block that says whether or not it should be written back at write back time. So the code path that you were asking about, that is in VM scan. So we've got a page on the LRU, and we want to we want to free it. So it's going to have to be written. If it's dirty, I don't know whether it might, and I think it can be at that point. If it's dirty, it needs to be written back first. So XFS needs that information to know which parts of the page to write back. So we could call wait for write back, or we might need to start write back at that point. I don't know whether write back would necessarily have started. But if it does, we'd need to wait for write back to finish before we get to that point. At the point where we've done write back, we could free that information. XFS doesn't. It leaves that information around for the existence of the page. But the fact that the page can't be split there is almost not the point. The point is that we don't particularly want to free that page before splitting it. So we don't split the page before freeing it. I think for Shemem, at that point we have to split the page because we can't guarantee being able to swap a huge page intact at that point. And so that's why we have to split it for Shemem. But ideally we wouldn't even split it for Shemem.
Yeah, I remember that a long time ago when I thought about split huge page for 5 pages, I thought that we can have it as knob and just forcing it to write back, and we freeze the page instead of splitting it. it may solve problem for most of users. So we have to split page for VM scan, and print page there is basically better if it's possible. If VM scan see page that it wants to split, it probably better to drop it if possible. What other cases we have? That's like immigration code, I believe, where we can also drop the page completely. So I don't know. Do we really want to support full feature split for file pages with back installed?
Yeah, so when we do split a page for file systems, we certainly need to write back any dirty data on it first, because this data is about the per page data is about to become out of date. So if you look at the XFS patches, I think what I have there already will do this. It'll if you're going to split a page, it will write it back and drop the metadata from it. I think if you look at something like invalidate page, you'll see that, because we might only be invalidating part of the page. And so if we're doing anything to the page, we just tell the file system, okay, write the page back, then we can drop all the per block information, because we can reconstruct the per block information if we need it later. But that lets us split the page at that point, because we've no longer got the ref count, because we don't have the extra private information, per page private information.
So where does this happen? Does it happen in VMscan? And is it a new piece of code? Because I think VMscan currently only handles a non-page splitting.
No, we do handle, we already handle file system page splitting for Shemen.
Okay, so yes, but is it handled in VMscan? I don't think it's handled in VMscan though.
So VMscan will call split huge page under various different circumstances.
To list, I think that's only called for unknown, page unknown and swap back. The check is if its page is anonymous and swap back, then it tries to split it.
No, actually we have directly, like if it's unknown and swap back, right. and else if it's transhuge still, we still try to split it.
Right.
But it will fail for XFS pages because of elevated pin count.
Oh, that part is new, I think. Split the file THP. Yeah, I didn't notice that part. It's relatively new. In there, let me see. Right, that's how it works. Okay, that makes sense.
Okay. So yes, those patches I posted, they are going to be. I'll post them again in a bit, but not immediately. I want to get some of the other stuff queued up for 5.18 first. The get user pages patches, those got some pretty solid reviews. So I usually go through and add the review tags from that I've already received for that series. I am building on that for 518. I'm doing more work with shrink page list. Shrink page list continues to be it's a ridiculous huge function. And it's currently using pages, and it really should be using folios, because obviously every page on the LIU list is in fact a folio. But it calls a lot of functions, so I've got a lot of prep patches, which then we kind of escalate through and eventually get to being able to do shrink page list, but it kind of ends up touching a lot of RMAP and mlock and swap and a few other places. So I was hoping to get that out today, but it's not happening. I've got about 200 patches or so into the Linux trees for folios, which means that I only have 125 left. Some of them have been kind of sitting around for a while, and I think I probably need to start either submitting them or abandoning them. But I've got things like, convert random chunks of swap to use folios, and convert random bits of the Shemem code to use folios. And I probably need to go and actually tie those up and submit them.
Matthew, what is status of multi-order entries in the XRA? Do we have it already? I just haven't.
The status of what in the XRA, sorry?
Multi-order entries.
Multi-order entries, yes. Those have been around in the XRA since I created it. They're used by DAX, and the last patch I submitted for 517 was to convert the page cache to use multi-order entries.
Oh, great! So it's there now, and I just hope that it can be useful to get rid of huge TLB oddities, like with this shift stuff. It can be helpful.
Yes, I also help for that. I keep trying to persuade Mike that he wants to start looking at doing this, but I haven't been successful yet in persuading him that this is what he wants to be spending his time on. He's got a few other huge TLBFS projects on the go at the moment, so I understand. It's not his favorite thing. But if he doesn't do it soon, I might have a go at it for him. Yeah, I think reducing the differences between huge TLBFS and THP is something I'm very interested in. One of the other things I'm interested in doing is getting rid of the page walker differences. If it's huge TLBFS, we go off and do this crazy thing where we return a PTE, but it's not really a PTE, it's a huge TLBFS PTE. And we've got all this other code that's already ready to work with PMDs and PUDs, but it doesn't get used for huge TLBFS, it only gets used for THPs. And I would very much like to get rid of that. I started looking at what it's going to take, and it's complicated by ARM, or ARM64 perhaps, because they have this thing where they do they let you use huge TLBFS to create, say, 64K pages, and then they've got that special bit in the page table that says, oh, this isn't really a 4K PTE, this is part of a 64K PTE. Even though you've had to walk down to the PTE level, it's not actually a 4K PTE, it's a 64K PTE. And so I need to figure out what that means. It looks a little bit more daunting than I had at first hoped. I thought it was going to be easy, and then it wasn't. So I stopped looking and I need to take another look at it.
So that's the contiguous bit, saying like multiple 4KB PTE, just the TLB can just using one entry to cache the contiguous one, right?
Yeah, that's the one. Okay. Yeah, so I think the only way you can use those right now on ARM is through huge TLBFS, and that's just something that we're going to want THPs to be able to take advantage of as well.
I wonder if it's possible to expose it to Core MM as a fake page table level. So instead of having PTE with HARC, we pretend that it's actually PMD and shift all upper levels by one.
It's an interesting idea. But I have a feeling that the places which are using that could actually just say, oh, this is a PTE, and not even look at the contiguous bit, but look at the PTE, turn it into a page, and then notice that page is part of a folio, and the folio is 64K in size, and just handle it as a 64K folio.
So in this case, it means just we will have fake PMD levels that actually part of PTE page table. And yeah, it can be difficult, but conceptually might work. Like basically, you split PTE page table, contiguous PTE page table into multiple PMD entries. But, yeah, it's fold backwards. Page table folding backwards.
Yes, page table unfolding. But I think we can get away without doing that. I don't think we need to present it to software as being a level of page table. I think we can just say, here's a PTE. Oh, you want to skip to the next contiguous group of PTEs? Well, you do the arithmetic and you're there.
Or just look at it like normal PTE mapped folio, and because they have that bit set, so the hardware will take advantage of that. So software can process like the same as we are doing now, right?
Exactly. Yeah. That's the route I was planning on taking. So one of the things I discovered, I had a bit of an oopsie with my test rig, and I ended up reverting to a config which didn't have transparent huge pages enabled. And large folios do not work terribly well if you don't have THP enabled. For example, you can't split a page because all that code is very much embedded in huge memory.c. So does anyone have any thoughts about whether we move that out of being THP specific and just being part of the MM, or whether we just say, you can only have large folios if you enable transparent huge pages?
Or the other way around?
I would personally want it to dissolve huge memory completely. Like it would be nice to fold it into, not fold it into memory.c, but split like memory.c into multiple chunks, like one for copy page range, one for page fold, one for whatever. So and it will have functionality for both small pages and huge pages, all in one place. It would be a nice way to work, I believe.
Oh, good. I'm so glad you said that.
Yeah, and I guess it's probably just say THP can be enabled only the folio is there. So it's like THP depends on folio, not the other way around. So all those kind of split things should be already enabled in folio. Then THP should be enabled naturally there, unless someone is really weird want to disable entirely.
Yeah, so I'm not actually making folios, large folios configurable. They're just going to happen.
Yeah, I just want to give that a third. It just the folio seems like such a basic concept. I think it shouldn't. The other code shouldn't be specific to PHP. It should just be there, I think.
Yeah, as a possible option to say that, yeah, we have folio all the time, but only have non-order 0 folios if each page is enabled. I think it's worse option, but yeah, it is there.
I agree that's the worst option. I think that's what we're going to have in 5.18, that you'll only get large folios if you have THP. But yeah, let's okay. Now that I'm hearing consensus on this, that we all think that you should just have large folios by default. I will start working towards making that happen.
Yeah, because if we try to make folios depend on THP, then we would also depend on Arc has THP support. So that flag doesn't exist on all architectures. That's a problem. Portfolio, in theory, at least, can be used on all architectures.
Yes, yeah, you're quite right. I was actually thinking about the M68K people who have no support for THP whatsoever, and they don't need to do anything like split a PMD or split a PUD because they're never going to be able to map those things. Their MMU just doesn't support it.
I wonder if you had any problems for non-MMU systems with folios, or it can be translated easily as well.
I don't know much about no MMU systems. Nobody's complained yet. I don't think a lot of people build no MMU configs. Dave, didn't you work on no MMU config systems?
Well, I rewrote quite a lot of the no MMU stuff for FRV, but that architecture's gone. I think we only have 2 left now, perhaps.
I think you can build ARM no MMU and M68K.
Yeah. But the PTA mapping is the problem for no MMU. So you could use large folios on it, but you just have to use kmalloc to get, or something like that to get them, and then you keep them until you get them back. In fact, you don't. Your folios don't even really need to be a multiple of a power of 2 multiple of pages.
We're not going there because folio order exists, and I'm not. No, shut up, Dave. Shut up. Don't tempt me.
But that would only be for a no MMU, and to be honest, it's not worth optimizing for that, I think.
No, I feel like no MMU is going away, no matter how much risk V tries to make it happen again. So let's see. I have a bunch of other patches in my tree. One that I might try and get into 5.18 is redoing set page dirty, converting that into set folio dirty, or folio set dirty. That's actually going to be changed to all the file systems, which I'm kind of tempted to just slam in as a single patch rather than try and, let's add a new dirty folio AOP and then convert everybody over to use it and then rip it out again.
You could union a pair of function pointers.
Then how would I know which one to call?
You just call the folio one, and it'll be the same as the page one when it comes out in the page-based file system. And because that one set the flag to say I want multi-page folios.
So I actually want to change the function signature. I want to pass the structured address space, which it's set page dirty is one of the weird ones which doesn't pass an address space. You're supposed to then look it up from you're supposed to look at page arrow mapping. And then there's a whole bunch of confusion around whether that's a stable pointer or not. So
Right.
I'd rather just pass mapping instead of getting them to look it up. And I want to change a couple of the parameters of ints. I want to make those size t. So yeah, I actually don't want to make it a union because I want to change a lot of things about it at the same time.
Fair enough. Yes, there's how many file systems still need converting? You know, do you have
I think it's about 30.
Right, because I have most of the work done in a patch for SIFs and a chunk of the work done for Ceph, but that gets more complicated because there's RDS, not RDS, RDB, the RDB driver, which is a block device driver, which both sit on top of a library in the net directory. Yeah, I've worked out some patches whereby I can hand iterators down. So the file, I've got patches to make the file system hand iterators down instead of list of pages. And I'm done the same on SIF, so there's only like half a dozen page references left in SIF, so you'd be glad to hear once that patch goes in. 9P and AFS are fully foliated. NFS, Tron won't talk to me, so I don't know what we're going to, who or what is going to deal with NFS. Oh, and by the way, the FS cache rewrite went in, which clears a whole load of patches out of my queue. That's all foliated. Well, actually, mostly it doesn't know about pages at all anymore. It just uses iterators. So now working on the NetFS write helpers, try and take away more bits of various network file systems. Currently managed to reduce, take away the read help, the VM, the ordinary read, part of the ordinary write, and direct IO read from SIFs, reducing it by nearly 1,200 lines of code.
Nice.
Yeah.
Yeah, SIFs has been ripe for cleanup for a while.
Yeah, and Steve French seems quite enthused of this patch, particularly with the iterators rolling down into down to the sockets. I get rid of loads of copies of lists of pages and just copies of data into pages.
Yeah.
So that's ticking along quite nicely. I'm hoping I'll have the right helpers in NetFSlib working within a couple of weeks, which then gives us a few weeks to stabilize them, bike shed them, whatever. And then, as I said, there's still NFS. Really could do with an LSFMM conference this year.
Yeah. Yeah, tell me about it. So that is actually scheduled for first week of May.
Yeah.
Yeah.
Haven't heard any, apart from the website, haven't seen any announcements about that.
Not scheduled, LSF.
Sorry?
LSF is scheduled for May.
Yeah.
Yeah, 2nd to the 5th, something like that.
I never seen any announcement either.
It's just on the website.
Hmm.
There's a web page about it, and that's all I know about it. Same place the previous one and the one before that, which were both cancelled, was supposed to be. So I guess they've got a deposit on the hotel.
Oh yes, they do. So to answer the question about the set page dirty, how many file systems? I'm not quite sure how many file systems, probably about 50, but I'm touching 78 files, 321 insertions, 309 deletions.
I'm hoping the set page dirty for the netfslib using file systems will all disappear into netfslib.
Yeah, I mean, you're still going to have teeny, you have teeny tiny little wrappers, because I've done this on top. I've done this on top of the current Linus's tree. So for the ones you've converted, it does make it does touch each file system, but yeah, it's very little. Very little code.
And I'm hoping to have a play with your set of patches that makes large folios happen. Because I did have that working with AFS in one of your earlier iterations of that.
Yeah.
I'd like to play with that. I can probably get that working quite easily on AFS because it's foliated. And it has worked before. It's just the changes to make it work in right begin and right end, which Linus objected to.
Yeah, I mean, take a look at how I did it in IOMap.
Well, yeah,
I
have a thing in the netfs right helpers don't use right begin and right end anymore. They do all that inside there. I copied before generic perform right, and then started modifying it.
Yeah, so basically exactly what IOMap does.
Yeah, it's definitely tending. So with the direct IO read, it now you give the network file system just gives the netfslib here's a function called to read something, and it gets handed an iterator and the start and file and says go read that for me please, and that takes care of the direct IO read, and it will take care of the uncached reading, and it takes care of the ordinary cached reads, and it'll be similar for that for the buffers as well. That's starting to look good. It's just looking at truncate now, and it's yeah.
Not to mention insert and collapse and the other stupid fallocate things that have been done over the years.
I don't know whether any of the network file systems actually do any of those. Yeah.
Lucky you.
NFS might. I haven't plunged my hand in there to feel around.
The other interesting one is dedupe. And so for local file systems, I was just looking at this. There's patches from me in the latest tree to it. For local file systems, we pull in both. We pull in the pages to the page cache, and we actually do a memcomp while they're in the page cache.
Right.
I suspect that is not a good thing to do. It's not the right approach for a remote file system. You really want to tell the server, how about you try and dedupe this? But again, that's actually, is there any support in the protocol for doing that?
No idea.
Yeah.
As far as I know, no. In all 5 cases, there soon to be 6 by the looks of it. EROFS is looking to use this as well.
Mm-hmm.
And I'm going to see if I can get OrangeFS and Fuse to use it also. But that's further down the road. And then, as I said, there's still NFS.
Yeah. Does Tron listen to Chuck?
No idea.
Okay. Because I obviously I work closely with Chuck, so you know I can see if he put in a word with Tron about stuff.
Sorry, that's kind of where the network file system stuff that I'm dealing with is at the moment.
Great, thanks for that. The one other thing I had on my list to discuss was page treble mapped. Z, I think this was something you were looking at for PUD mappings.
Yeah, I had some working code in the old tree, and I think the difficult thing is how you're going to map the PMD on the the 1 gig page that. And what I was doing is say every 512 page, I say that's is a PMD page in a PUD page, and storing those kind of the and using, I think it's second or third page of the first 512 one. So using that and storing the compound mapping, or should it be the PMD mapping there? So is kind of it is working, but a little bit complicated there. But still, in that way, I think it can even evolve to four times mapping or even fifths. But still takes the code become complicated, because when the page size go to 1 gig, you need to check every 512 looping through that. But otherwise, it's still working.
Yeah, I mean, I was actually thinking about what it takes to implement folio map count if you've got a page that's a gigabyte in size, because you end up having to scan through 16 megabytes of struct page in order to sum up all the individual PUD, PMD, and PTE mappings. And I think surely there is a better way to do this than scanning 16 megabytes.
Right, or the other way solution is just we do not allow triple mapping. It's only double mapping only. It's only PUD plus PMD, PMD plus PTE. If you want to get lower, just split the page. I think that simplifies.
But split page can fail. And what your course in this case?
I'm sorry. What can fail?
Split huge page. If you try to split at like page 4 time and split fails, what you're going to do? There is no reasonable way to handle it in this case.
So I missed the split what? You mean split the PUD page?
No, you're talking about like don't allow to have page triple mapped. So you have like double mapped page or something, and you get page fault on this page again, that will make page triple mapped. You try to split huge page to avoid this. Split huge page fails. What are you going to do in this case? Sig bus?
Okay. Or yeah, that. Or in that case, if that case, when page fault happens, you are falling to a like 1 gigabyte page. You should just provide the PMD mapping instead of PTE mapping, right? You already have that page there. You're not adding new pages. Could that work? Say, if you're folding a large page, instead of just folding to the minimum like PTE, you're folding the supported one, so you don't need to split.
No, it's so. For instance, what happens if you have like 1 gigabyte page, then you fork, and then you mremap 4K from this region to some other place? So yeah, I'm not sure that we have like a way to support 1 gigabyte right now, and yeah, I'm not sure that we will ever be. I don't know.
Yeah, there is something if you think about. If you remap that with 4 KB, either you can try to split it and then you have double mapping on the 2 megabyte one. If the split fails, you just say the remap fails. That's the trade-off, right? Otherwise, we need to get more complicated code to support triple mapping, which might even not work in other cases.
As the case, like again, 1 gigabyte page folded in U4, and you do M and map on 4K region in middle. I don't think that anybody will accept failing M and map here. M and map should work. So you will get, by one M and map, you will get multiple single PED mapping from the parent, multiple PMD mappings in the guest, plus multiple PTE mapping, not in the guest, in the child, multiple PTE mappings in the child. So yeah, we can try to invent some tricks, but I don't know. My point is that relying on split huge page is not an option because it can fail.
Or how about, this you cannot do shared. Can you mmap when you do fork? Can you mmap to share so both parent and child write to the same? I'm just thinking, if we do mmap, can we just do copy and write on that sub 4KB page? But in that case, the parent and the child cannot share that page anymore.
Yeah, basically, I don't see a way to support 1 gigabyte without compromising some existing APIs. So
yeah, I agree. There is some compromise we need to make if we want larger pages.
maybe we can accept like 1 gigabyte pages in VMAs that cannot fork and cannot whatever be remapped and everything. So in this case, in some limited way. But in this case, do we really want to bring all this infrastructure to support 1 gigabyte pages if it's not widely adopted?
But at least for the initial support, we may not support those triple mapping or even double mapping for the 1 gigabyte page. And otherwise, it's too much code there.
I mean, I don't even like the current map count implementation for 2 megabyte pages, because, you know, in order to calculate the map count, we still have to scan 512 times 64 bytes. That's what, 32 kilobytes of memory in order to find out what the map count of a folio is. So I know I talked about this with Kirill briefly. Maybe we can change the definition of map count so that it's the number of VMAs which have this mapped rather than the number of PTEs which point to this folio.
I remember Shu also talked about something, just putting the mapping just in a single counter instead of individual pages. That's probably also work. But I couldn't remember the way how it's going to implement it. But I remember I agree with that solution before, so probably it's the way.
I thought the discussion was moving in a way that map count is useless and we should do things without it.
Yeah, if
Or
only
the
we had David
questions
Hildebrand
that
on the
we,
call.
yeah.
I mean, if we can do without map count, if we can just have a single bit that says this page has been mapped, well, it may still be visible from any user process, and we cleared that bit upon unmapping it from every user process, I think that might serve us just as well.
I wonder if there's any critical workload that relies heavily on optimization in AirMap that checks map count to cut short.
Yeah, truncation could be sped up by that, because truncate has to go and invalidate mappings on a page if the page has ever been mapped. If it hasn't, then it doesn't need to do that.
Yeah, but if it hasn't, it means that it will likely have. Okay. So if this page wasn't mapped, but this files was, then we will have to do a lot of work. If it mapped multiple times, but this page is not mapped anywhere. I just wonder if there is a lot of cases where it's actually useful and bring meaningful speed up for workload.
Because I have to deal with this in AFS, where a third party change happens and I get an invalidation notification from the server, and I have to go and zap the contents of the file. Well, I need to call the server again, but what I do first is try and zap all mappings and set a flag on the inode to say, next time you do any file system operation like page in or read or write or whatever, go and recheck the server. Because I don't want to do it in the notification thread, because I need permissions to do that. But if I can say this page isn't mapped anywhere, I don't need to send an API for it, or whatever is done to clear out all the TLB entries.
You can already skip that, and in fact, I think if you call the appropriate function in mm/truncate.c, that optimization is already done for you.
Yeah, so we need something to do it, but it could just be this page has been mapped at some point, because most of the pages we're dealing with haven't been.
Right.
So we don't necessarily ever need to get rid of it until the page is released or invalidated.
Yeah, I mean that's true for file system pages, but for anonymous pages, it is a bit different.
Yeah, I suppose.
I mean, every anonymous page is mapped. That was that was how it got
case, created. Doesn't matter, because they are mapped.
Now they can get unmapped and put into the swap cache, where they can be retrieved from later.
But when
it can get mapped or
presumably
it's still pinned by get user pages, so it can be around for a while after a month.
But if an anonymous page is pulled back out of the swap, presumably because someone's tried to access it and swap.
Yeah, and usually that would be through a page vault, and there's then the weird cases that look more like an attacker than somebody doing something serious. You know, somebody took the page and stuffed it into a pipe and then tried to do a read and write. Yeah, but you know, these are the CVEs we have to deal with.
Yeah. Or VM splice.
Yes, exactly. Yeah.
Or just don't worry about VM splice. Just assume it still maps as long as the page is there. How often does that VM splice actually get used anyway?
It's almost never, except in exploits.
Take it away.
It's been proposed before.
I guess this usage should be documented in the man page.
All right, well, it's 5:02. We've taken basically the whole hour talking about my problems. Does anyone else have anything they want to talk about today?
I think since the multi-index X-array is already in the PHP support, I was trying to do the split PHP to any order. I'm just testing it, and it seems there are some counting issues. Like, what's the 30-page counting issue? I think it's on my side, so I need to check is any implementation or something is missing there. Yeah, that's most related thing. The other thing I'm doing is going the other way, trying to able to allocate 1 gig page from the body allocator. So there is a lot of background work is going on. So hopefully one day I can get this done.
Yeah, I've seen a few of your patches along those lines. Yeah, one of the patches that's kind of sitting in my backlog at the moment is changing the page allocator to be a folio allocator by default. And so the page allocator still exists, but you can choose to use the APIs to allocate folios instead.
So I do have an issue that perhaps you could suggest something for me. With the cache, the file system cache, pages come in from the network and then I start shoveling them out to the disk. Do you have a good suggestion as how to throttle that?
No, I don't.
Because what I'm doing in the write helpers is I'm moving the writing to the disk effectively into the make it the VM schedule it by marking the pages dirty, even though they might be on a read-only file on the read-only file system. And then the VM will call me occasionally to say, "Come write these out." But I still need some sort of throttling so that I don't just try and write out several gigabytes all in one go, bang, and the thing goes, ah!
Well, isn't it naturally throttled? I mean, if your network is faster than your storage, why are you caching your network on your storage?
In case the network goes away. Or you have lots and lots and lots of machines, so like a render farm, that suck down lots of data and then deal with that data a lot, but they don't want to go to the server because then the server, every time, because then the server will fall over. So it's not always about network speed, it's sometimes about network capacity. But these rendering units often have local storage and cache what they've got on the local storage.
But do they have slow local storage? Doesn't seem like a render farm that I've ever seen.
Well, the network link may be faster than the storage. So I can download gigabytes of data, and then it's slow to write out, relatively slow to write out the disk. It might be on an SSD, for example. Yeah. It's just, I've come across occasions where I've got so much data, it starts behaving really weirdly, and I think it's because it's trying to do too many writes at once, right? Because it's got loads of individual things all trying to write at the same time. Maybe the MM thing isn't the right venue for this. I should probably take it to FSDevel or something.
Yeah, well, I mean, MN is kind of a consumer of this information, or it used to be back when that information used to exist. We used to have things, we used to have throttling and so on, and then Yen said, "Oh, it's all broken," and took it away and didn't tell anyone. So Mel has fixed that in the VM in the last few months.
Perhaps I should talk to Mel.
Yeah, or at least read Mel's patches. But it's all based on, how long did it take this to complete, and are pages being found again before they're being before their write back has completed, and if so, maybe we should stall a bit. It's heuristics and it's hard.
Yeah, and it's not necessarily one right answer.
No, I mean, just because the machine has enough bandwidth for you to write everything, it doesn't necessarily mean they want you to write it as fast as you can. So maybe the right comparison here is RAID, because RAID rebuild deliberately throttles itself to a certain percentage of the bandwidth, as far as I remember.
Yeah.
How does trigger readbacks? Because I thought readbacks are usually controlled by dirty ratios. So doesn't directly trigger readbacks, at least for XFS. I guess we're talking about XFS.
We might be talking about any file system, to be honest.
Well, the write back is being triggered from NFS or AFS, but it's writing from the pages attached, the page cache attached to that, to XFS or Btrfs or ext4 typically.
Oh, okay, I see.
Yeah.
So I think what's that guy's name? Dave Trainer has done something. He removed a callback in address-based ops. I think it's called a red page. And then without that callback, will never be able to trigger readbacks directly.
Right.
The only, even it's under memory pressure, and I'm trying to free some pages because that callback is missing, then cannot directly cannot interfere with readback process. So only way readback happens is the dirty ratio is the dirty ratio reaches the threshold.
Yeah.
So that would be you, at least I think FS would have more control with dirty ratios, and in terms of readbacks, and FS would have more control when the dirty ratio threshold is reached.
Yeah, it's complicated because the data is attached to one file system, but is actually affecting the bandwidth on a different file system, in my case. Anyway, I think I need to go and find
because there's only one dirty ratio. You can't have two different dirty ratios for different file systems.
Yeah.
There's only one global dirty ratio, at least if let's say if you are not using memory C groups. But if you use two different memory C groups for two different memory file systems, then yes, you could have two different dirty ratios. And the one being affected probably, or the one affecting the other could probably use a lower dirty ratio, so that the readbacks happen more frequently instead of, oh, okay, I have like many dirty pages. I have reached this ratio and I have reached this threshold. Then I try to read everything out. But then it happens like every few seconds, they read a smaller bunch of pages instead of a large bunch, which could congest network.
Yeah.
Sorry, folks, I need to drop out.
I'm just guessing.
It's 40 minutes past. See you next time.
Okay,
Bye.
Thanks, Bill. Yeah, I think I'll stop the recording now. Thanks all for coming, and we'll talk again in 2 weeks.
Okay, bye.
Yeah, bye.
Good awakening.